Let's have some fun with Spark streaming. So I've already kicked off my Hortonworks sandbox here. And let's open up an SSH connection to it. And we will log in as Maria_dev as usual. All right, so let's start by configuring Flume to talk to Spark streaming instead of dumping data into HDFS. So in our previous section, we set up Flume to monitor a spool directory inside our home directory for new log files that got dropped into it. And we directed that data into HDFS. So this time we're just going to direct it into Avro instead, which is just a communications protocol that we're going to later connect to Spark streaming. So I prepared a configuration file for Flume that does this. Just type in wget media.sundog-soft.com/hadoop/spark streaming flume.conf. And let's take a look at what's in it. All right, so this is actually identical to the previous example we used in Flume for connecting our spool directory to HDFS, but we changed the sync. So everything is the same except for the sync variables here. So now we're saying that the sync type is Avro, and it's going to communicate on the local host on port 9092. Everything else is the same. Our source is going to be a spool directory that's monitoring home MariaDev spool for new data. It's going to append timestamps to it because why not? Although we're not actually going to use that information, so you could take that off if you wanted to. And we'll set everything up to communicate through a memory channel. So all we've done here is set up Flume to monitor a spool directory and dump the results of any new files seen in that directory through Avro on port 9092. Make sense? Great. So let's take a look at the Spark streaming script itself. And to do that, we can say wget http://media.sundog-soft.com/hadoop/spark flume, pay attention to capitalization there, .py. And if we do a cat spark flume.py, you can see that there's a script there. Let's actually look at it in a real editor here that I have on my desktop just so we can talk about it a little bit more easily. So here's the actual contents of that script that we just downloaded. Let's talk about what's going on here. So there's a little bit of housekeeping here. First, we're going to set up what's called a regular expression, which you might be familiar with from earlier experience. But basically, it's a pattern matching language that says, this is how I'm going to actually extract information from a line of Apache log data. So this is basically encoding the format of a line of an Apache web server access log. Each line consists of a host that the request came from, some identifier that's not used, a user, a time, a request, which includes the URL that was actually requested from the web server, the status code, the size of the request, the referrer, and the user agent. Okay, so all this is fancy regex language to pattern match against each line of a Apache access log and extract the host, user, time, request, status, size, referrer, and agent from it. Okay, and if you want to learn more, there's regular expressions is a whole course in itself, so you can look that up on the Interschnitzel if you so desire for more detail. Next thing we have here is a map function that we're going to be using as part of our script. So this actually takes a raw line from an Apache access log and extracts the URL that was requested from it. So all this does is it takes that regular expression pattern that we defined above, runs a match on that against the incoming access log line of data. If it finds a match against that pattern, then it will group that into a dictionary and extract the request field from it. So that's going to consist of 3 different fields. The second one, we're going to split that out into its components, and the URL will get plucked out of the second field of it. So this code just takes the Apache access line and tries to extract the URL that was actually requested as part of that access. Okay, so down here we get into the guts of Spark streaming itself, and you can see there's not a lot of code here. If we think about what's going on here, we're processing data in real time over a 5-minute sliding window across a cluster potentially. Pretty awesome that this is the only code you need to do it. So first thing we do is we set up a Spark context object, and we just give it an app name so that if we're looking at this in the web UI for Spark, we know what to look for. We are then going to set the log level to just the error level so we don't see a bunch of spam in the logs as we scroll by and run this thing. And then we set up a streaming context based on that Spark context with a batch interval of 1 second. So this means that every 1 second we're going to look for new data and create a new RDD within our dstream that contains that 1 second batch of information. All right. Now to hook it all up to Flume, all we do is we use this Flume utils package that we imported up top here. See, PySparkStreaming.flume import Flume utils. So that contains all the logic needed to actually connect to Flume through Avro. And we're going to tell it to use our streaming context and listen on localhost to 9092. Now this is only one of two ways of actually using Spark Streaming with Flume. This is what's called a push model, where we're actually pushing model from Flume into Spark Streaming using Avro. So, it looks like we're pushing data from one Flume agent to another as far as Flume is concerned. You can also set up a pull model, where you actually use a custom sync within Flume to actually establish a more bidirectional relationship between Flume and Spark Streaming. And that's actually a more robust way of handling this if you were doing this for real in production. But it's a lot more complicated, so I don't want to go there just right now. Remember, this course is really more about breadth and depth, so I just want you to learn enough about Spark Streaming to be dangerous. And believe me, we can be dangerous. All right, so once I have that, we've created here a dstream object that we've named Flume Stream. And we can apply this map operation that just extracts the actual line of information from each line of data that comes into that dstream over time. So remember, this Flume Stream dstream has a 1 second batch. So every 1 second, this lambda function is going to extract the actual line of data that was received from that chunk of data from the past 1 second. So it looks like this is all just happening all at once on the entire dstream, but it's not. Because we're operating on a dstream, these operations are happening repeatedly over and over and over again as each batch of information is received. We will then call map on the resulting dstream to extract the URLs out of those access log lines. And here's where the fun part starts. Then we use reduced by key and window. So first of all, we're going to map those URLs to a tuple of the URL and the number 1. And then we can just add those all up, all those ones together, to count up how many times each URL appears. So the trick here is we're mapping each URL to the URL and the value 1. And then we use reduce by key and window to add up all of those ones for each URL that appears. So that gives us a count in the end for how many times each URL appeared over our window. So because we're not just reducing by key, we're reducing by key and window, I'm providing a function for how I combine things that are received, how I subtract things that are received. I provide a window interval of 300 seconds, which is 5 minutes, and a slide interval of 1 second. So what this is saying is, every 1 second, I'm going to compute the URL count that was seen over the past 5 minutes for each unique URL. Okay. Finally, we'll sort the results so we can print them out, which is all that's going on here. Sort the results by how popular each one is and print them out at each second. So again, that batch interval is what's driving this whole process. So every 1 second this happens. Okay. And specifically, this 1 second slide interval is what's kicking off the computation of that window computation. All right, so to kick it all off, we need a couple of things. One, we need to set up a checkpoint directory. So whenever you do a windowed operation, it needs to maintain state somewhere. And by giving it a place to write that state, it means that if things fail, if our cluster were to go down, we could restart the job and pick up where we left off based on the persistent information written into this checkpoint directory. So you do need to provide a checkpoint directory for your script whenever you run a windowed operation in Spark Streaming. After that, we just kick it off with the start operation on our streaming context, and we just await termination from when we actually stop the job and stop it cleanly. So that's the entire Spark Streaming script right there. So let's actually run it, shall we? I'm going to close out of this. All right, so a couple of things we need that we talked about. First of all, we need to make that checkpoint directory we just discussed. So I am still in my home directory here. Let's make dir checkpoint so that that checkpoint directory we refer to in the script exists. We also need to tell Hortonworks that we're using Spark version 2 because this particular version of the Hortonworks data platform comes with both Spark 1.6 and Spark 2.0. So we're going to say export Spark _ major _ version equals 2, like that. All right, and then we can actually kick off our job. So why not? Let's actually start listening. So we can say spark-submit -- packages. And this is where we're going to specify the Flume connector package for Spark Streaming, org.apache.spark : spark-streaming -flume _ 2.11 : 2.0.0. And this is saying I want the Spark Streaming Flume connector package for Scala 2.11 and Spark 2.0.0. Now, if you're using a different version of Scala or a different version of Spark, you'll want to substitute the appropriate numbers there instead. These are the values that work with HDP 2.5, okay? Finally, the name of the script itself, sparkflume.py, and that should kick off. And since Flume isn't actually running yet, it's not going to be receiving any data yet, but we should see it chugging away every 1 second, trying to figure out what's been received over the past second, and indeed, it's doing that. So let's kick off Flume. Let's start a new window. Maria_dev, and let's move this over here. So let's start Flume. First, we'll cd into user HDP current Flume server. And from here, we can say bin/flume-ng. We're going to start an agent with the default conf folder and the configuration file that we downloaded from our home directory /sparkstreamingflume.conf. And we're going to use the A1 agent. So that should kick off Flume, configured to listen to our spool directory and output data to Avro, where it gets pushed into Spark Streaming. All right, so we can ignore that error. It's okay. Let's start up a third window here, Maria_dev, and we will actually put something in there. So we have a spool directory. Let's copy some information into there. So let's get a really big access log. So let's say wget http://media.sun.soft.com/hadoop/access_log.txt. So this is a larger actual access log from Apache from a website that I own. Let's drop it into the spool directory. So copy access_log.txt into spool, and we'll call it, I don't know, log22.txt or something, doesn't matter. So now that that gets dumped in, what we should see happen is Flume picking that up, and Spark Streaming should then pick it up and start to aggregate it over the past 5-minute window. So let's watch. Check it out. It worked. So we can see that over the past 5 minutes, we picked up that single access log file, and it turns out that xmlrpc.php got hit 68,000 times. And you know, this is actually interesting information, because it's when I ran this analysis the first time, I said, that's kind of interesting. It turns out some hacker from a country that shall not be named was actually trying to break into my website by trying to exploit some security vulnerability in WordPress, it turns out. So by seeing this data, it alerted me to go plug that hole. Let's do the same thing again. Let's drop it into a second one. Let's copy the access log into a new file called log23.txt this time. And what we should see is that as that gets picked up, all those numbers should double, right? Because we're going to process the same log a second time, and all of those individual URLs will be processed twice as often. So let's see if that works. Indeed it did. Very cool. Everything doubled. And you can see that actually increased over a couple of seconds there. So it actually took more than 1 second for Flume to get all that data into Spark Streaming. But we saw those intermediate results as it was received. Now, if I were to sit here for 5 minutes and were to allow that 5-minute window to expire, we would see these numbers go back down to 0. But I'm not patient enough, so you're just going to have to take my word for that. So let's recap what we've done here. We've set up Flume to monitor a spool directory, publish that data through Avro to Spark Streaming, and we've used a windowed interval in Spark Streaming to aggregate data in a stateful manner across the past 5 minutes. So there you have it, an example of using Spark Streaming to do something interesting and analyze a stream of data in real time as it's received. Very cool. We can exit out of this window here and Control-C out of our Spark Streaming script. And don't worry about all the errors as it's shutting down. And we will also shut down Flume. All right, exit out of that, and we're done.